Okay, let's do this two-prop hypothesis test. Pause the video and read the question. Okay, we want to know if we have evidence that men are more likely to buy books online than women. We know this is a two-prop test because we have two groups. We have men and women. We also have two sample proportions. We have two sample sizes. We know it's a hypothesis test because it has the word hypothesis in it. So first thing we do is write down our population and success. Population is adults and success is buying books online. So let P represent the proportion of adults that bought books online. Notice we did not mention either group here. If you mention your groups here, you have done goofed and everything will be wrong. Here are our groups. We have our sample for men and our sample for women. 21% of the sampled men bought books out of 222. So X, our number of successes, P hat times N is this number, and X must be a whole number, so we round that to 47. Similarly for women, 18% out of 208. So the number of women in the sample must have been 37. Remember, X must be a whole number. Men are group number one here because they have the higher sample proportion of success. Whoever has the higher P hat, make group one. Makes everything easier. If we do that, then writing out our hypotheses is easy. The null hypothesis is always there's no difference between the groups. P1 minus P2 is 0. Every single time. As long as you make group 1 the one with the higher P hat. That's equivalent to saying P1 equals P2. They buy books online at the same rate. Our alternative is that difference is positive. P1 is bigger than P2. The sample suggests men buy books online at a higher rate than women. Again, as long as we always choose our group 1 and group 2 properly, this is what we'll always get, as long as it's not a two-sided. We're going to use an alpha level of 5%. So we type everything in our calculator. So we're going to go stat, over to tests, and we want a two-prop test. So we scroll through until we find one that says that, two-prop test. Hit enter. We type in all of our parameters that we know, all of our statistics. It is important to get these in the right order. So X1 was 47. Remember, if we do not type a whole number into the X's, the calculator is going to get mad at us. 222, 37, and 208 right here. Our alternative will always be greater than. In fact, we can just leave that there. So highlight greater than. P1's greater than P2. Hit calculate, and we're done. Here's our p-value. That's all we wanted from here. We should check these numbers just to make sure, but this is what we want, our p-value. So our p-value is 18%. That's a giant p-value. Remember, small p-value is strong evidence. Remember also, if you ever get a p-value bigger than 50%, you've done goofs somewhere. So our p-value is 18%. That's much bigger than 5%. If p is greater than alpha, we fail to reject the null. We do not have strong evidence of the alternative. So we have to write this sentence: we do not have strong evidence the proportion of men that buy books online is greater than the proportion of women. We're saying we do not have strong evidence of this statement right here.